So mission, get you ready for the polar test. I'm going to start by putting a point on this polar graphing paper, and I'd like you to see if you can figure out what its name is. There's quite a few different names for a point like that blue one I just put in there. And I'd like you to see if you can come up with a few. So I would recommend that you take notes right now and that you pause the video, sketch out things. I know it's easier to just watch, but you'll also remember 10%. So let's see if we can up that by taking some notes. Okay, that spot would be, well, let's look at the R, the radius. So from the center here, we go out 1, 2, 3 rings. So that's 3, comma, and then the theta, the angle, is 5 pi over 6. That's one way to name that point. Now, another way to name that point would be to give the rectangular coordinates for that point. The rectangular coordinates for that point, I'd need to draw a triangle around it and then figure out the x and the y. Okay, well, I know the radius, that's 3. And could I go x squared plus y squared equals 3 squared? Sure, that'd be true, but it wouldn't really help me find my x and my y. So I also know this angle. Since these are in pi over 6s, then that's a 30-degree angle right here. And so if that's a 30, then I can set up, well, I could set up the whole equation, sine of 30. Sine is opposite over hypotenuse, right? And so that would be y over 3. And then I could times both sides by 3. But it would have been faster to just remember that y is r sine of theta. Now the theta here is technically 5 pi over 6, not 30. And that's important because sometimes that's going to give you a negative answer. In this case, would it? No, because y is a positive number. But all I'm trying to say is this is supposed to be theta, which is really 5 pi over 6. So if I just go directly with that, it's probably better than setting up these triangles because it's easy to forget how to get your negatives in there. Okay, so this x, why don't we just go right to x is, definition from polar is r cosine theta. And I know r, and I know theta. My r is 3, and my theta is 5 pi over 6. So cosine of 5 pi over 6. Now, if I needed to actually complete this, I would probably just go back to what is cosine of the reference angle, but I just got to be careful with my negatives. Okay, so cosine is adjacent over hypotenuse, x over 3, and so this would be cosine of 30 is, so it's going to be 3 times cosine of 30, and then I'm going to have to use cosine of 30 to do a 30, 60, 90. Better draw myself a little reference triangle here. Here's a 30, 60, 90, 1, 2, square root of 3. And so cosine of 30 is root 3 over 2. So then I go 3 times root 3 over 2. But then I got to remember that this is a negative because x is going in the negative direction. So it's negative 3 root 3 over 2. So sine of 30 was easier. That was just a half. And so this is, the y is 3 times sine of 30, which is a half. So 3 times a half is 3 halves. So my x was this, and my y came from over here, was 3 times a half is 3 over 2. There is my x and y coordinates for that polar point. Okay, next topic that's really important is being able to take a point like we have here and give other polar names for that point. All right, so clean this up here. And if I needed to give a name that uses a negative r, that confuses a lot of people, and you do need to understand this. So if I wanted to rename this point except using a negative r, then that means negative r's are like on the opposite side, okay, of the origin. And so if I follow through that same line, but I go 3 in the other direction, that would be over here. Okay? And so then I say to myself, okay, that's the mirror point that I need to get this whole negative r thing. And now that point is really what? 3 comma 11 pi over 6. Now, is that the same point? No, but they're kind of like sister cities. They're related. They're directly across the origin and the same radius from each other. Okay, and so their angles are obviously related too. So if I needed to get this as a negative, I would say that it would be negative 3. That would take this point and bop it over there, and 11 pi over 6. Okay, so there's how to get it with a negative r. Now how about how to get it with a really big r, but positive? Well, then back to where it was in the first place, I'm going to change pen colors here and say that was how we got there in the first place, and that was 5 pi over 6. But if I add 2 pi to that, that'd be another way to say the same angle. So 3 comma 5 pi over 6 plus the 2 pi. 2 pi is really 12 pi over 6. 12 pi over 6 plus the 5 pi over 6 would make 17 pi over 6. That's another way to write this same point. It's just the same point over and over and over again in different polar styles. All right, and how about if we needed a negative r and a negative angle? Negative r, you obviously have to say negative 3, but then I'm back to this point is being reflected over there. And what is that point except using a negative angle? Well, to get to this little black point here, we would go down, so that's negative pi over 6. So this spot right here is 3 comma negative pi over 6. And if I want to reflect it over here, it'll make its r become negative. So we have negative 3 comma negative pi over 6. All right, so that's several different ways to make your polar points, and that's important for you to understand if you're really going to understand polar. All right, this next part is about conversions. So this is, well, is it polar or is it rectangular? Because you're going to convert from one form to the other. This one's in polar, and I can tell because it has r's and it has thetas. And my job is to get the r's out of there and get the thetas out of there. This one's actually a little too easy. We wouldn't give you anything this easy because we already have r sine theta right there, and that's just y. You're supposed to know that. What is that list? In fact, I'm going to give it to you right now. X is r cosine theta. Y is r sine theta. That's the one we needed for this. There's a few other things. X squared plus y squared equals r squared. And you could convert that equation over to just r. R equals square root of x squared plus y squared. It's just taking this original one and taking the square root on both sides. And then, last but not least, tangent of theta equals y over x. See how this is in polar and this is in rectangular? This side's in polar, this side's in rectangular. So these are little ways you can change things over. So this one will be too easy. It's just take r out and you'd put in square root of x squared plus y squared, because it's down here. And this one, you'd take out the r sine theta and you'd put in a y. Now, they can ask you to now solve for r or now solve for y. So you have to look at the directions. But unless they tell you you have to solve for something, don't do the extra work. This one's been converted. It is in rectangular now. All right. So now, let me give you another one like that that's a little bit more difficult. If I just say r equals negative 3 cosine of theta. If I'm going to need to convert that over, actually let me change that to sine. If I had negative 3 sine theta, because we just did that one a second ago, we're kind of familiar. It's a lot like the one above it, but there's no r over there. See, I can't change this in for a y. I need an r sine theta. And if I try to multiply both sides by sine theta, I'll just end up with a sine squared theta. So how could I get an r there? Well, I can times it by r if I want to. I'm going to just times it by r. Okay, r sine theta is the same whether you put the r before it or after it, right? So I'm going to times that by r. To do that, I have to also times this by r. All right, so that gives me an r squared here, and I know that one. That's on my list. And over here, I have negative 3 times r sine theta. I just reversed them, and well, there's my y, and there's my x squared plus y squared. X squared plus y squared is equal to negative 3y. And that is now in rectangular. Okay, so that's converting. This is another converting. And let's go the other way. We've got rectangular, and we need to convert it over to polar. All right, so to get rectangular out of there, I got to replace all my x's and y's. I see that I have a, oh, wait a minute, I'm sorry, there's supposed to be a negative right here. Otherwise, this problem's going to be a lot harder. So, sorry about that. X squared plus 3x is equal to negative y squared. And why did I do that? Because then I can add y squared to both sides, and I'll have x squared plus y squared. See, I'm just going to add y squared to this side and add y squared to that side. And I'll have x squared plus y squared plus 3x is equal to 0. Why'd you do that, server? Because I wanted this, because I know what x squared plus y squared is. It's r squared. And if I wanted to get the 3x out of there, I can't really replace the 3, but I can replace the x with r cosine theta. Yay, I'm done. That's supposed to be a 0. Sorry. Let's try that again. That's just a 0. Okay, so how do I know I'm done? Because I've got this all in r's and thetas. Now, if the problem had said you must solve for r, then I'd have more work to do here. I'd have to factor out an r and get the r's alone. Let's see, I'd have r comes out of this one, and there's r in both of them, right? And if you can factor it, you should. So r comes out, and then I'd have r plus 3 cosine theta, and then I'd have to set both of these parts equal to 0. So anyway, if I had to solve it for r, I could. All right. So let's get this next one. This is not a convert. This is a find the intersection of these two. And if you know what polar graphs look like, cosine's usually over off to the side, unless it's got a negative like this, in which case it's probably been flipped over here. And then the other one is just r equals 4. Now, if you made the r big enough, it's possible that two circles might not even touch, and then there would be no intersection, okay? But don't worry, we're going to make sure that they would touch. And so let's say that it looked something like that. Where do these two touch? This one's not here anymore, it got reflected. So it's like, where are these two circles going to hit each other? Now, why is that important? Because these are points. And so often kids will just solve and tell me the angles. That's not the question. Yes, there is an angle here, and I don't know what it is, and I'd like to know what it is to be able to tell you the point. I should be able to say the r and the theta. The r I already know. The r is 4. It just comes down to the angle. But you need to give your answer as points. We are asking for intersection points. All right, so now we'll do substitution. The 4 goes in here. 2 minus 2 cosine theta. Subtract 2 from both sides. 2 equals negative 2 cosine theta. Divide by negative 2, divide by negative 2. Negative 1 equals cosine theta. And, ooh, I can't draw a triangle for that. It sounds like circle trig. I better find the spots where cosine is x, right? cosine is -1, so x is -1. That's the spot where x is -1. I'm going to label it, it's -1 comma 0. And that's my spot. And that means pi is the answer. Notice there's only one answer. Apparently these two circles only touch once. Why is there only one answer? Because there's only one spot where x is -1. Okay, so a really common mistake answer is to say, so the answer is pi. That's the angle. The question was, where do these two touch? And it's a spot in polar, and it's got to have an r and a theta. And so the answer is 4 comma, r is 4 because of that, 4 comma pi. Okay, so that's where those two cross. And last but not least, we have graphing polar. And in this case, because of the way we're having to do tests nowadays, we can't make you actually graph it on graph paper. So let's just focus on getting the points. If you had to graph them and just kind of sketch them on a blank piece of paper, you should be able to find polar points. All right, so let's find these spots. Notice we've given you the thetas. It's a lot easier than trying to like give you an r and make you figure out what angle would work. We give you the angles, and we always give you nice ones, because you're not going to be able to use a calculator for this. It would make the test, kind of pedantic. So anyway, if we're going to take this theta, I'm going to put in 0 for it, and I'm going to see what happens. This is r equals 6 cosine of, 6 minus cosine of theta. Try that again. And it's cosine of 0. So for each one of these, you're going to solve a little equation like I just wrote. I just substitute in 0 for theta, and now this is 6 minus cosine of 0. What's cosine of 0? You better know how to do your quadrantals. Cosine of 0, this is where 0 degrees is, and that's the spot 1, 0, and cosine is the x, and so therefore it's 1. So it's 6 minus 1. So r equals 5. And you just do that for each one, for each spot, and you plug this in to the next little equation. R equals 6 minus cosine of theta, but theta now for this one is pi over 3. Okay, so what's cosine of pi over 3? Better know your classic right triangles. Here's a little 30, 60, 90, where if that's 30, the other one's 60, so then this is 1, 2 square root of 3. So what is cosine of 60, also known as pi over 3? Cosine is adjacent over hypotenuse, that's 1/2. So 6 minus 1/2. And that's r equals 5.5. So here's 5.5 right here. See how that works? All right, I'll just finish it off. This one would be r equals 6 minus cosine of pi over 4. Man, making me draw every triangle here. So I'm going to have to draw 45, 45, 90, classic right triangle. 1, 1, square root of 2 is what I use. Some people use root 2, and 1 because it fits with the unit circle better. All right, cosine of pi over 4 then. Cosine is adjacent over hypotenuse, it's 1 over root 2. This is our first one where we'd have to leave it weird. Cosine of pi over 4 was, if this is one of my 45-degree angles, this would be 1 over root 2. I'd have to leave it that way. 6 minus 1 over root 2. And that's exactly the way you just leave it. That's in exact form. Now if you wanted to, you could substitute in 1.4 for square root of 2, but then you got to go 1 divided by 1.4 and try to figure out what that is. That's not very fun. So we'd let you leave it like this. Okay, and then the last one's pi over 2. Ooh, yay, that's one of my quadrantals again. That's this one, and that spot is 0, 1. And so then that is, it's the x of it, and the x of it is 0. And so this part becomes 0, so it's 6 minus 0. That was, again, r equals 6 minus cosine of pi over 2, but cosine of pi over 2 is 0, so that's just 0, so this is just 6. There we go. There's a list of points, and if you just graph those, you would have graphed r equals 6 minus cosine theta. All right, that's all I've got for you. Have a great day.